Okay, this should be the last video dealing with feature control frames relating to profile. I'm going to use just one example of many here in the book, showing some of the many different ways we can use profile. Again, it's a very powerful tool. And because it's a very powerful tool, it is often misinterpreted, misapplied. I'm always a little bit leery of it, but it is here in the standard, and if it's used correctly, you can control a great many things all at once. And this is kind of a good example of an instance where we have a composite control. On the previous video I explained where we could have a number of different features that all have a individual spacing one to the other, and that tolerance needs to be tight. But if we consider that group of features, those holes, as a pattern, we can allow the pattern to shift around a bit, but the spacing not so much. Here's an example where we have a single feature, but it's a complex feature. It's got a number of different radiuses. If you look at the illustration, which is figure 8.19 in your handout, it's a number of different radiuses. It's a number of different XY positions for the centers of each one of those radiuses, all defined by basic geometry, just the way it should be. So this is a good example here of another use for a composite control. Now I want you to notice that this is just a block with a weird kidney-shaped hole in it, but you'll notice that there are datums. There's a datum surface for A. So if I have this part, this eraser, let's say, and let's consider this eraser that part, that means that I have to set this part on 3 contact points for datum A. Datum B would be this surface. I would contact with 2 points, and datum C is this point, a single point for datum C. That's 6 contact points, 6 degrees of freedom. So that means that this block, if I am touching all of these surfaces all at once, as I must, the part is fully constrained. It can't translate in any direction. It can't rotate in any way and still meet the requirement of touching all those data points. So it's a fully constrained part. Now, not all parts need to be fully constrained, and we'll talk about that a little bit more when we get to position. But anyway, just think of this as a block that is locked in a vise sitting on parallels. It is fully constrained, it's not going anywhere. Okay, so now we have this weird cutout shape. This might be something that was water jetted or EDM'd, or even just machined. So just a milling machine that comes in and cuts these profiles. And the definition of the part is all here. It's all defined in basic geometry. Now what we're going to try to do is make sense of this feature control frame. Okay, so I've showed you several times how we're going to read this. We're going to sort of follow this arrow up. First thing we come to is the all-around symbol. So that means that whatever controls we put here are going to apply to all the different radiuses, all the different straight lines, everything on this part. The entire perimeter of this part is going to be constrained by a tolerance zone. And in this case, it's actually going to be constrained by 2 tolerance zones. How do you get 2 tolerance zones? Okay, so we'll go to the feature control frame. We see that we're dealing with a profile tolerance. In other words, whatever shape is there, we're going to draw a boundary around it. Now, what is that boundary? We're going to read from the top down. We'll see that there's a 0.8 millimeter tolerance, and it's referenced to datum A, B, and C. But let's take a look at what that tolerance is first, and then we'll talk about the datums and what they mean. The tolerance zone is 0.8. We know it goes all the way around this part. So I'm going to draw that tolerance zone, that's 0.4 that way. .4 that way, so it's a total of 0.8 wide. Okay, so anywhere within that boundary, if you were to chalk that out on a piece of material, and you could say, well, I can cut this profile anywhere. Well, it's a pretty big number, and you know, if that were exactly the case, then you could really just skip some of these curves and everything. We could just cut anything we wanted that fit within that profile. So that's not the intent. The intent here is to say, I can allow the position of this pattern to move around on that plate within that much. But in terms of the shape of the part, in terms of its actual profile, I really want a much smaller tolerance. I want a tolerance zone that is 0.1. So I'm going to draw a 0.1 tolerance. And that's going to fit much closer to the true position, or the perfect geometry that we've defined. Okay, so now the orange boundary is this, the blue boundary is this. Now we just have to figure out what those two mean, and what it means is that the feature, in other words, the part defined by all the dimensions and tolerances, that is the feature itself, without regard to where it is on the plate, but just the size and the orientation and the form of all those curves and straight lines is controlled by this. So I called this in the previous video the feature control. So the bottom feature control frame is going to always control the feature itself. I called it the feature control. Well, in GD&T we don't call it the feature control. We call it the feature relating tolerance zone framework. Nobody says that. Even in the standard they abbreviate it as FRTZF, which is a stupid abbreviation, so they don't even use that. We just call it the Fritz. So this lower part right in the standard is called the Fritz. And that relates to controlling the size and shape of the feature itself. The upper tolerance zone is called, I call the pattern control, but the GD&T standard calls it the pattern locating tolerance zone framework. Again, a clumsy, cumbersome terminology, and nobody uses it, but we call this the plots. Okay, plots is actually a word in Yiddish. It doesn't mean anything good, so bottom line is these are both stupid, cumbersome terms, but this is the best we can do to make them at least palatable to English speakers. And we call this upper feature control frame the plots because it controls where the pattern is. So if you think about this cutout, the feature itself, this weird shaped hole, it's a bunch of features. It is a radius and a straight line and another radius. Each one of those are individual features. They're just grouped together and they're joined together. So we think of that as a pattern of individual features. We define a tight tolerance zone, defining the size and variation of the individual features in that part. And then in the upper feature control frame, the plots, we say that if you make this hole with all these different features, if you make this within this tight blue tolerance band, we can allow that whole tolerance band to move around within the orange boundaries. So in other words, cut the hole precisely, and then we won't have to worry so much about where it is in its actual position. So here we're controlling, with the blue, we're controlling the size and orientation of all those features. With the orange tolerance zone, we are controlling the position of all of those features all at once as a separate pattern. Okay, so this is going to take a minute to sink in. I think it's a couple good examples in here. I'm going to encourage you to read those, especially the means this portion of the example 819. I think it'll become a little bit clearer. I wish they had come up with something less cumbersome than the PLTZF and the FRTZF, but that's what's there. But the concept is a sound one, where the individual features of a pattern of features can be controlled separately from the pattern itself. And this is composite control. It is used only in relatively sophisticated design environments. You aren't going to see this real routinely. So that usually when you see this, it's thought through well enough that it doesn't make utter nonsense of the drawing. So if you see this, you can be pretty confident that it's going to make some sense. And in order for you to make sense of it, you have to realize that these are really two separate controls of basically the same thing. The upper one controlling the positional location of all of these features as a group, and this one defining the tolerance of each individual feature one to the other. Okay, so none of that's going to be on the final. I don't want you to worry about it. I do want you to at least be able to recognize these terms. I want you to be able to recognize this weird looking double stacked feature control frame as a composite control. That's all I'll ask you to do, is just recognize that you can do this with a single symbol and two feature control frames. And the reason I want you to know that is that, unfortunately, when we get into positional controls, we'll see that we'll be able to actually stack two separate feature control frames one on top of the other, where we don't have a single symbol. So it does get a little bit more complex. I just want you to recognize that if you have the single GD&T symbol, it is a composite control. Okay, so we're going to leave profile at this point. After this video, I'm going to start putting up test number 2. I hope you have gotten through test number 1. If you have not, you have got to contact me. I'll probably have to reinitialize the test. I would like everybody to be done with test number 1 by the end of this week, so that we can take test number 2, and closely followed by the final. Now the final is already prepared. We've got it on Canvas. What I want to do is go through orientation and run out. We're not going to spend a whole lot of time, another week, talking about that. And then we will have a review video so that we can sort of focus on what's going to be on the final. Given the circumstances here where there's very little communication back and forth, I'm sure there are questions. Nobody's asked me any, but I'm sure there's a little bit of confusion. So what I want to do is have a review of test number 1, just to highlight the answers and why the answers are what they are so that you fully understand it. I've already gotten a little bit of feedback. I understand that all the ones that you second guessed turned out to be wrong. So that's kind of my rule, is that go with your gut on this stuff. You probably understand it better than you think. Don't let your doubts get the better of you, and pick an answer that your first instinct didn't point you to. So again, just think this through, try to get the concept, but I'm not going to ask you to interpret anything like this on any of the tests. I just want you to recognize the composite control, and I want you to recognize these two terms and which one is which. This one is the plots, this one is the frits. So the plots and frits, if you think of it in that sense, it's going to be plots first, frits on the bottom.